Hi, this is Chris, and we are taking a look at question 8 in section 4 of SAT Practice Test 3. So here it reads, the average number of students per classroom at Central High School from 2000 to 2010 can be modeled by the equation y equals 0.56x plus 27.2, where x represents the number of years since 2000 and y represents the average number of students per classroom. Which of the following best describes the meaning of the number 0.56 in the equation? So if we look at 0.56, hopefully when looking at this equation, we can recognize that this equation is a version of slope-intercept form, except they just have the numbers plugged in. So we have y equals mx plus b is our slope-intercept form, and b is your y-intercept, and m is your slope, which in this case would be the 0.56. So for this particular word problem, let's see if we can understand what that slope would mean in context. And I'll tell you a couple key words that we want to look for in an answer choice. When you're dealing with slope, a slope, by definition, is a rate of change. And so think of slope conceptually as rate of change. And let's think of the type of words that would be associated with a rate of change. So for rate, that means that you're very often going to see words like per or each, which indicate that something is a rate, that it's going to be looking at how quickly something is moving. And for the change, we're very commonly going to see something that indicates an increase or a decrease. So when we see rate of change, those are a couple key words that we want to keep in mind that we should look for. And this is worth jotting down and making sure that we keep in mind for slope on a conceptual level. A lot of times people look at slope and they look at 2 points on a graph and they think of rise over run or y2 minus y1 over x2 minus x1, which are really important things to know about slope. But on a conceptual level, we want to make sure we can identify rate of change in terms of the language used in a word problem. And let's see how that applies here. So for question 8, if we look at the correct answer choice that describes the meaning of 0.56 or the meaning of our slope, let's check here. Total number of students. Well, that doesn't say each or per. That doesn't show an increase or a decrease. That's just a set value. That would be a constant. And same thing with average number of students. Again, that's still just a constant value. That's not showing a rate of change. There's no change in the value. Let's see answer choice C. It says the estimated increase. Okay, so this is one of our keywords, identifying slope. An increase in the average number of students is per classroom each year. So there's a lot of good language in here. Let's say we'll keep that one on the table for now. And let's take a look at D. The estimated difference between the average of students per classroom. So we see per in there. And we see this word difference, which is not really one of our key words to identify slope or rate of change. And if you take the difference between values, you're really just getting one numerical result. You're getting a constant. So regardless of what that is the average of, this is still going to be just one constant value. Now, our correct answer here is answer choice C. And again, we don't even have to look at this question as a whole to understand the exact context or to do any sort of calculations, plug in numbers. You can do that, but for answer choice C, hopefully by recognizing the appropriate language for identifying rate of change, we can pick that confidently and move on very efficiently on a lengthy word problem like this. Let's take a look at question number 9. And here it says Nate walks 25 meters in 13.7 seconds. If he walks at this same rate, which of the following is closest to the distance he will walk in 4 minutes? I know we've mentioned this before on other problems, but I'm still going to put it here in our key color of red to make sure that it's something that we know. Here we have 3 given values. And we have one unknown, which is what the question is asking for. And we want to think to ourselves, whenever we see that, this can probably be solved in some sort of proportion. And with proportions, we want to make sure that we're just aligning the corresponding values. 25 meters in 13.7 seconds. And then they want to know how many meters, that's x, in... Now this part's a little bit tricky. And that's why in question 9 here we have this one extra step. They say 4 minutes. Well, for us to treat this just like a simple proportion and cross multiply and solve, we have to have the same units aligned. And here we don't. This is in seconds and this is in minutes. But both of those are units of time. So the conversion should be pretty easy for us. And if we know how many seconds are in a minute, then we can make that conversion here. So here, 4 minutes. 1 minute is equivalent to 60 seconds. And if we multiply that out, our minutes would cancel, and we are left with 240 seconds. And let me minimize this and just move this over to the side a little bit. But that would be the equivalent of setting up a proportion with equivalent units here. 25 meters in 13.7 seconds is going to equal x meters in 240 seconds. So now we've got the equivalent units aligned, and we can treat this like a simple proportion. We can cross multiply and solve. And so when we go to do that on this, 13.7 times x will give us just 13.7x, and then equals, when we multiply that out, 240 times 25 will give us 6,000. We can divide by 13.7. And luckily, since it's section 4, this is our calculator section, we get 437.96 as our number of meters on this. And I don't see that exact answer, but luckily this is one of those questions where they just want whatever is closest to the distance, so it's okay for our answer to be slightly off. And here the closest value to 437.96 is 450 meters, which is answer choice B, our correct answer to number 9.